Hey everybody, this is Mr. Beckstrom, and today we're going to go over section 5.1 in the book. This is on measures of dispersion, and specifically we're going to be looking at how to calculate the standard deviation of a set. Let's talk a little bit about what a standard deviation is. So a standard deviation is basically the average distance that values in a data set are away from its mean. So, for example, if I had an Olympic race, like a 50-yard dash, and everyone finished that race within about 7 to 8 seconds, I'd have a really small standard deviation, because if the average speed of that race was 7.5 seconds, and all of the values were within about a half a point of that mean, then that would be my standard deviation, around a half a point. And there's an actual calculator for it here, but it just measures on average how far a value is away from your mean. So, for example, if we had a Krispy Kreme donut race where we had people of all kind of ages and sizes kind of doing this race here, we had some people finish it in 15 minutes and other people finish it in 2 hours. Then my standard deviation would be very large, because maybe my average speed was right around an hour, but the average distance to that speed, for example, the person that ran it in 15 minutes was 45 minutes faster than the average, so that's a difference of 45, and we're just looking at an average of those distances. All right, so here's the formula. Here is a kind of a guide to computing the standard deviation, and we're going to go through the whole process here and see how you do it. So just a second here. All right, so let's take a look at this data set right here. We have 2, 12, 13, 11, 14, 5, 8, and 9. So the first thing I want to do is compute the mean of this data set, and that is denoted by an X with a little bar over the top. And we should know how to do this from the last section, so let's go ahead and 2 plus 12 plus 3 plus, add them all together, and then we're going to divide by the number of values we have, 1, 2, 3, 4, 5, 6, 7, 8. So divide it by 8, and we get the nice even number of 8. So that is our mean. That's our average number of the set. And you notice that, for example, the 2 is 6 places away, the 9 is only 1 place away, the 14 is 6 places away, 3 is 5 places away. So if you look at all of those differences and you take the average of those differences, that's how we're computing the standard deviation, or that's the idea of it anyways. All right, so let's go ahead and find the standard deviation of the set. That's around the average that each of these values is away from this 8. So first thing it says is compute the mean, which we did. And let's see if I can fit it all on here. So the first thing I want to do is write down my X values. So I have 2, 12, 3, 11, 14, 5, 8, and 9. 5, 8, and 9. And usually I would want to put these in order, but you don't actually have to if you don't want to. Now the next thing we do is we're going to find this is called the deviation squared for each score. So in order to do that, this is this part up here. So the first thing we're going to do is find the deviation. So that's just the X minus the mean. So that's the data value here minus 8. So we get 2 minus 8 is negative 6. 12 minus 8 is 4. 3 minus 8 is negative 5. 11 minus 8 is 3. 14 minus 8 is 6. 15 minus 8 is 7. 8 minus 8 is 0. And 9 minus 8 is 1. So this is the deviation. Remember, you take each x value and subtract the mean. Now we want to find the deviation squared. So that's going to be, whatever that deviation is, we're going to square it. We're going to square it. So negative 6 squared is 36. 4 squared is 16. Negative 5 squared is 25. 3 squared is 9. 6 squared is not 18. 36. 7 squared is 49. 0 squared is 0, and 1 squared is 1. Okay, so that's what we did here. Now, we're going to add all these deviation squareds up, and we're going to divide by n minus 1. N is the number of values in the data set. So we have to add all of these up here. All right, right here. So we have 36 plus 16 plus 25 plus 9 plus 36 plus 49 plus 1. And then we're going to divide by the number of values minus 1. So we had 8 values, so we're going to divide this by 7. All right, and we get that right there. So this is about 24.6. 24.6. And then the final thing that we do, oh, by the way, this weird symbol here, that's the summation symbol. It's a Greek sigma, and it means that we take all of these values and sum them up. So that's what that means. Sorry if I missed that. The last thing we do is we take the square root of this thing. So going to my calculator, you can either write it out or you can just do second square root. And I'm going to do second answer. That puts in my last answer there. And I get about 4.96. So about 4.96. And we should really go out one more decimal place than our original values. So it should be 5.0 because that's going to raise up. So our standard deviation in this case is approximately equal to 5.0 when rounded to one decimal place. All right. I also want to take a look at the coefficient of variation. Talk about the coefficient of variation. And what this lets us do is it lets us compare two groups of data that may have different means and different standard deviations. So let's take a look at both Chihuahuas and St. Bernards. Chihuahuas and St. Bernards. Right? See, I don't even know how to spell Chihuahua. I tried to spell it once. It was horrible. All right. So let's say Chihuahuas have a mean, that's an average weight, equal to 7 pounds. 7 pounds. And let's say they have a standard deviation equal to 0.6 pounds. That means on average, the weight of a Chihuahua is around 0.6 pounds away from 7 pounds. So sometimes it'll be more, sometimes it'll be less. But on average, it's about just a little over half a pound, more or less than 7 pounds. Now let's say St. Bernard has an average of 200 pounds. 200 pounds. And they have a standard deviation equal to 10 pounds. So let's say on average, the weight of a St. Bernard is around 10 pounds, different than the average. That's what that standard deviation means. Now let's say I said which of these two groups was more extreme, like which one had the greater variation, which one's data values were more kind of spread out. You might look at that and you might say, well, that's definitely the St. Bernard because, you know, they have a 10-pound standard deviation, whereas the Chihuahua only has a 0.6 pounds. So this data group is far more extreme. But that's really not true because we're kind of comparing apples and oranges here. These are two very different groups, and they're going to have different coefficient of variations. And that's what this is here. This kind of gives us an idea of how extreme that group is, or how spread out those data values are away from its mean. And it gives it to us in a percentage here. And then the larger percentage, the more that those data values are spread out. So let's kind of figure that out. So the coefficient of variation for our Chihuahua, the little Chihuahua here, that's going to be equal to the standard deviation, so 0.6, all over the mean, which is 7, and that is going to be times 100%. And the coefficient of variation for our St. Bernard is equal to 10. That's our standard deviation over our mean times 100%. So when we look at both of these groups and we take into account the means and the standard deviation, let's see what we get. So the first one here is 0.6 divided by 7 times 100 times 100. And we get about 8.6%. So this is about 8.6%. So that would be that coefficient of variation. And then this one here is going to be 10 divided by 200 times 100%. Now it's going to be about 5%. 5%. So you notice that when we take into account the means and the standard deviations, that the Chihuahua's values are actually spread out more than the St. Bernard's, even though the St. Bernard has a much larger standard deviation. All right, everybody, that's all I have for you today. If you have any questions, please let me know, and I hope you have a great rest of your